Hello everyone, in this video we will discuss how can we use the Siemens i7-1200 PLC and the TI portal to trigger and get the result from Keyence IV2 camera sensor. Based on the one previous video, we discussed how can we program the sequence control structure. I will base on this sequence structure to program the camera trigger and the inspection result register. Talking about the sequence control structure, I will prepare the video link under this video. Before the PLC program, let's go to the Keyence website and download this important manual, that is the IV2 series user manual field network manual. And once you download this manual, let's go to this manual chapter 3 cyclic communication and find out the chapter 3 cyclic communication and find out the section this. So operating procedures of cyclic communication. So this page shows the actual timing chart to trigger successfully. So its key idea is we send the trigger request signal, and this signal need to be turned on until we get this busy signal on. Once the PLC receives the camera turn to the busy, so we can shut down this trigger request. And once this is busy signal from on to off, so the result based on this trigger that is ready. So at this moment, we can register this result. There's one signal which is really annoying, that is this, the result update complete, as shown in the screen. This is the A trigger. Once it got an A trigger, it will turn on. And once it's got a B trigger, it will turn off. So once you trigger, it will turn on one time, and next trigger it will turn off. So we can now use this result update complete rising edge to register result. The best way to register the camera result, that is this, the busy from 1 to 0, this falling edge to register the judgment result. So this result update complete will cause misunderstanding. So all the Keyence camera will use this result update complete as this way. So the best way to result the camera, barcode reader, or other Keyence cameras, we better use this busy falling edge. So that is one of the motivation we use the sequence control. Because if you only rely on this busy falling edge, it will cause some trouble in some cases. For example, if you switch over the program of the camera, the busy will still show the on and off. It will still cause a falling edge. So from PLC wheel, if you only use this falling edge to register the camera result, sometimes the PLC will register the wrong results. So that is the motivation we use the sequence control. Using the sequence control, the camera judgment result will be only registered after we trigger and got this busy falling edge. Alright, that is that IV2 camera trigger timing chart. To use the sequence control to implement this trigger and the result register, so we will separate this timing chart to different steps. So we'll assign the different steps like this way. So at the beginning, that step sequence that is 0. And once the condition ready, we will move to the step 1. At step 1, we will send the trigger to the camera. And then, while waiting for the busy signal, once the busy signal turn on, we will move to the step 5. And then after this, the busy signal will be on. During this time, the camera is processing the image. And once it's busy from on to off, that means the camera is finished its job and the judgment result will be ready. And when this busy from 1 to 0, we shift the sequence from 5 to number 10 step. At that moment, we can register the judgment result. And after this, probably we would wait 100 milliseconds and we move to the next step, 15. And the 15th step will be the last step. At that step, we can move to the 0, waiting for the new trigger. This is the idea we use the sequence control to trigger and register the result. Okay, let's move to TI portal. Let's implement using this way. Okay, so let's go to the program blocks. And in one previous video, I introduced how we can prepare this sequence structure. That sequence structure, the overall picture, the detail step will be like this. So this is step 1. We start from the step 1 and move step by step. So I will leave this template here and copy and paste, use another one. So as this FC11, I will copy it and paste and name it block sequence 2. IV2 camera trigger. And don't forget, rename it, that is 12. Don't forget, from this main, we will call this 12, drag this FC12, drag here. So this OB1, this main program will call this FC12. And in the meantime, we will leave this template DB block. In this template DB, it has the important tags and array for the sequence control. So I will copy and paste, leave this template DB here, and that is the DB block sequence 2 IV2. DB block sequence 2. Okay, so let's double click. Go into the FC2. So this time, this DB block sequence, we will change to the sequence 2 here. So this is the initial step. Once we get the step 0, it will equal to 0. So this bit will turn on. And this is the initial start. So change to sequence 2. And we put the part present and by some condition. And this will be used. And this sequence start will be the sequence 2. And sequence complete will be the sequence 2. Okay. And we change to 2. Okay. That means once this sequence start from the 0, we are waiting for the part present. And then once we click the start button, the sequence will move to the step 1. At the sequence step 1, we will trigger the camera. So let's move to the step 1. At the step 1, here, so firstly I need to change this sequence to 2, and this is the sequence 2, the step 1, and we will trigger the camera. And here I can create a parallel logic and add here. So we will trigger the camera, that is the Q500.0, the IV2 trigger command. And this is the condition we move to the next step according to our timing chart. So the condition to move from step 1 to step 5, that is the busy from 0 to on. So the condition at here, that is the sequence 2. So the condition at here, we will use the camera busy signal. So IV2. So find out that busy, that is the input 502.0. So once the busy turn on, we will move to the next step. This is the sequence 2. And this timer, we can set a 0, because once we receive this busy signal, we can move to the next step. Okay. And this time block, change to 2. And this step number, we change to 2. Okay. We move to the step 5. Okay. And in the meantime, the step 1, we can name it trigger IV2. Okay. This is the trigger step. And once we got the busy, it moved to the step 5. So this is step 5. At step 5, basically we are waiting for the camera processing the image and waiting for the busy turn off to move to the next step. So at this step, the condition to move to the next step, that is a busy turn off. So we will use this busy. And once the busy from on to off, so we move to the next step. That is the condition to move to the next step. So here, let's change the sequence 2. Okay, and here we could put a little bit timer here, for example, 10 milliseconds or 20 milliseconds. So this timer is 2. And we move to the sequence 2. and then we move to the step 10. Okay, the reason why I put 20 milliseconds, that's because once the busy go off, so next step we will register the result. So here, waiting for 20 milliseconds, make sure the result is fully ready, and then we register the result. Okay, so this step, waiting for IV2 processing. And once the busy go off, we move to the next step, step 10. So this step 10. So at step 10, at this moment, we can trigger one signal. That signal allows us to register the camera result. So here we can create another tag here. So this output could be used to register the camera result. For example, we can use one M bit, for example, 200. Register command. Okay, at this step, it will turn on this register command. So it could be used to register the camera result. Okay. And here, this condition, we can hold this signal for 20 milliseconds or 50 milliseconds to make sure there will be enough time to turn this bit on and register the camera result. So here, this timer, we can put 50 milliseconds. Make sure the PLC can catch this signal and register the camera result. And here, this condition, we change to sequence 2. Okay, and the condition here, we can also involve this not busy. Right? If the camera is not busy, make sure so we are registering the correct result. So it will turn this on. So this step 10, that is send the command to register the judgment IV2 judgment result. Okay, next step is 15. At 15, basically we finish all the sequence to register and the result. So at step 15, we can go back to the 0. At this step, let's change the step 2. Let's change the sequence 2, sequence 2. Okay, and the sequence 2. And this is the sequence 2. And we can put a 0 timer here. And once we register, so we can move to 0. This is the last step. So this is sequence complete. Sequence complete. Okay. So we move this sequence to number 2. So this step 20 comes from the template. So we can delete this step 20. So this sequence complete will be set at this step 15. So at the last step here, we will set data sequence 2 sequence complete signal. And then we can delete this network. Okay. So this is the last step. Okay. And move to the next. If by some reason, for example, communication drop or the camera lock out, so by some reason, if our sequence stop in the middle and without any response, we can set 0 to this sequence, allow this sequence start from the beginning, re-trigger the camera. So this timeout will be used as this. That means our sequence 2, if the sequence number not equal to 0, and if the camera got something error, for example, the IV2 error signal, right? Or if the camera not at a run mode, for example, IV2 run mode. Okay. If this is sequence at here, so after 120 seconds, so using this timer sequence 2, and we can set this sequence 2 to 0, recover this sequence. right? And complete signal. So if the part not present, so we will reset that sequence 2 complete signal. So this is sequence 2. Okay, let's review at the beginning of this sequence. Okay, to initiate this sequence, we need a part present and the sequence start. And this sequence shouldn't be complete. And other than this, we still need a couple conditions that come from the IV2. For example, firstly, the IV2 should be ready, right? Should be ready. And IV2 should not in busy status. And the IV2 should not have an error. Okay, this can guarantee the camera is fully ready. And once we present the part and once we start this sequence, so the camera will be triggered. Okay, other than that, that's the trigger. And waiting for the processing and here. So this command will be used to register the actual result. So this variable will be used to register the camera actual result. So I can copy it and scroll down and use a network 9. Let's say this, register the IV2 results. So at here, I can use this signal and use one trigger signal. The trigger from this bit logic, let's use this P trigger. And then this is the result. So that result, that is come from the IV2 judgment OK signal. And then we latch in the actual result. The actual result could be M201.0. That is the actual camera judgment result. If it's turned on, that means the part is good. If it's turned off, that means the part is bad. Okay, so this could be the IV2 inspection OK result. Okay, and here we need one more tag here. So we can use, for example, 1000. Okay. And this is the IV2 register command ONT. And this is the P trigger. And this is the P trigger of this judgment register command. So I will type in the name and then rename it command P trigger. POS. Okay, so now we finish all the logic for the camera trigger and the result register. And this is the OK result. If the part not present, we can reset this OK result. So at here, I can put a parallel logic. And if the part not present, we can reset this result. So let me put here reset part not present. Or if we retrigger this camera, so by default, this OK result should be off, waiting for this actual pass. So we could put another signal here. And here we can use the step 1 signal. At step 1, we trigger the camera. So at that moment, we can reset that signal. So that means we can use this sequence 2, step 1, to reset that camera result and waiting for the new result update and a new register. So at here, we can use this sequence 2, step 1 and reset this OK result, waiting for the new register at here, right? Okay, so let's save and compile download. Okay, the compile has error. That's because I forgot changing this name. DB12 should be. Okay, it shouldn't be the same name at here. So let's click this properties. and rename this block to 12 and save the project, download. Okay, now we download the program, and firstly we need to check out if this controller can communicate correctly with this device, this IV2 camera. So we can go to the device configuration. Let's go to the network view and hit this go online. Check out the online status. Alright, now it shows everything okay. That means the Profinet communication between the controller to this device, they all correct. So now let's go to this FC12 and let's click this monitor. Let's scroll up and find out this initial start. So from this input, we can see the camera is ready, it's not busy, and it's not in error mode. Now the sequence is at 0. And if we present the part and if we fire this sequence, it will go through this sequence, trigger and register the camera result. Okay, and our camera final result come from this bit. Okay, to monitor this important variable, we can create one watch table here. Add a new watch table. So we can rename this watch table to IV2. Okay, so we can drag, this is the camera input. We can drag the couple important camera status. Camera ready, drag here. This is very convenient. Camera busy, camera error. Okay, and the step number, and this is step number, so we know what the current step number, right? And then this step complete signal and this final result, this IV2 inspection OK result. Okay, let's click this monitor. It shows camera is ready, it's not busy, and no error here. So let's fire this part present. And let's fire this sequence start. This sequence will be very fast because this camera response is very fast. And keep in mind that Profinet communication, the current cycle time is just 4 milliseconds. So this sequence will be very fast. Okay, let me turn on. Meantime, you can watch this sequence number here. It will run very fast. So let's trigger. Boom. So now it's stuck at number 5. Let's check out what's going on here. That's the beauty of using this sequence. So we know where has a problem. So number 5. Now the sequence start at this number 5. So the camera is keeping busy here. What's the reason? Let's check out. So probably this busy signal has something wrong. Let's double check. Let's go to the hardware configuration. Go to this station and find out our busy definition. So here. So this busy signal comes from the byte 2, bit 0. So let's find out. Okay, I know the reason. That's because we assigned the wrong bit for this busy signal. This busy signal comes from the address 2, that bit 2. It should be this, 502.2, rather than this. So this is the result available. Okay, so we use the wrong bit. So let's click this go offline. And to rewire this tag, we can do this. If we go back to the program, so this IV2 busy actually should be 502.2. Okay, we can click and rewire the tag rather than rename because we need to use a different address. So let's click this rewire tag and rewire it to 205.2. Okay, here. So after we rewire, if we shift back to the hardware configuration, this time, this 502.2, that is a IV2 busy. Okay, so we troubleshoot this problem, and let's download this controller. So let's download this controller. So because this is rewire only programming wise, so it won't restart. Okay, again, let's click this monitor. Okay, here, this address, we need to prepare 502.2. Okay, so let's start from the beginning. So let's represent this part. Okay, now the camera is ready, not busy and not error. This busy, this time is the actual not busy status. So actually it also shows using this sequence control, we know what the problem in our program or what the problem from our device. So it's easy for us to troubleshoot. Otherwise, if I trigger and the camera didn't get the trigger, if we got this problem behind, it's really hard to troubleshoot. The problem come from this busy signal. The busy will assign the wrong tag or wrong variable, right? So firstly, I'm sorry to assign this busy to a wrong input address. But it's also a good chance to demonstrate using this sequence control is very easy for us to troubleshoot where's the problem. Okay, so let's present the part again. And let's restart this sequence. It will be very fast. Watch this sequence number. And now this inspection OK by default, that is a 0. Okay, so let's trigger. Boom, very fast. And now the inspection OK is on. So the sequence 2 shows complete. Okay, if I remove the part, okay, it's waiting for our new trigger. In the meantime, let's shift to the camera side and let's check out what the current condition of the IV2. Okay, as we can see, I put a good parts here. So the 3 tools, part 1, 2, 3, this is 3 square, shows OK here. And the entire results shows OK. And the result shows OK. So let's go back to the TI portal side. Also, we can check out the individual inspection tool result. That is a 1, 2, 3. There's 3 tools. Okay. And from this watch table, we can also set up that IV2, monitor the IV2 inspection tool 1, 2, 3. So I can drag them 1, 2, 3. We can see the current inspection tool, and these 3 tools, they show good result. And now I'm going to load a bad part. And that bad part, inspection tool 1 should be failed. That's because it lost 1 piece on that part. Okay, let me reload this part. Okay, I reload the part, and let's turn on this part present. It should come from one actual sensor. The sensor is used to detect the part present. Okay, and I'm gonna start this button. That basically come from a push button or a pump out button. Okay, let's start. And by default, this inspection OK is off. It's waiting for the new register. So let's turn on this sequence start. Okay, as we can see, now this sequence shows complete. Okay, and now we can see this inspection OK shows off. And in the meantime, the inspection tool 1 shows off. Tool 2 and 3, they are all good. And let's shift back to the IV2 camera and check out what the current status. So as we can see, the IV2, this inspection tool 1, it got a fail. So that's why the individual inspection bit shows off. And from this part wheel, that result shows a bad. Okay. So that's the inspection. Next, let me load an entire byte part and let's check out this inspection tool. In the meantime, we can also monitor the judgment result come from the sensor directly. That is the IV2 judgment OK. That come from the input. This come from the camera directly. And this is our PLC internal bit to register that result. Okay. So let me load a byte part. So let's reload. Let's turn off this part present. Okay, I load a 1 byte part. Part present, turn on, and this time watch carefully about this status and this register result. Okay, I'm gonna start this sequence very quick. So turn on, boom, very short time. So we see all the inspection tool turn off. That's because that is one totally byte part. And sequence complete shows complete. That means we finished this inspection. All this results show off, including this. That means this part is definitely a totally bad part. Okay, if we see the actual picture, so as we can see, this is the actual part. So it loses 3 pieces here. That's why the individual inspection tool 1, 2, 3, they all off. And the entire judgment OK signal from this camera shows off. Okay, I will reload a good part. And now I'm going to retrigger from PLC side. You will see the change from this screen. Okay, I just load a good part, turn on the part present, and let me turn on that sequence start. Boom, it got a trigger. You can see 3 parts present, it got a new trigger at here. So 3 individual tools turn on. And let's shift to the TI portal side. So this time we can see the sequence complete turn on. Okay, and this sequence complete turn on, and the actual signal from the camera judgment OK, individual inspection tools, they all good, turn on, and this register result, inspection OK result, turn on. That means this part is totally good. Okay, that is the sequence control for this IV2 camera trigger and the result register. So if we quickly review this sequence steps, if I shrink this network view, so actual step is very simple. Alright, this is the sequence control to trigger and register the camera result from Keyence IV2 using the Siemens i7-1200 controller and the TI Portal 15.1. Alright, that's it for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.